So I prepared some sort of a storyboard, okay, and I named that Road to Edge, okay. I'm trying here to explain how did we as a telco community or a service provider or CSPs or vendors, how did we reach like a conclusion that we need to go to Edge and actually what is Edge. So as a start, I would like just to explain the legacy mobile network for those who I'd say not maybe familiar with that, because that's our starting point. So normally, and here I picked an example of a typical, 4G and 3G mobile core. So we always divide the network into two main parts, the access and the core. And that's actually the legacy name of the teams in any CSP. So the access is always like the radio part, the E node B, the node B, the RNC. These are like the modules constructing the radio and the access part. And it may take other names, right? In other department, in the other CSPs, like it can have the access, the RAN, sometimes the BSS. So that's actually the name of the teams governing these modules. And we have the core, delivering the core services, as you see here in this light blue color, like MME, SGSN, S gateway, P gateway. And you always have some sort of connectivity requirement between these modules, either between the axis and the core, between the core itself, between the axis by itself. So this is what we call the transport or the network or the transmission teams, and it all depends on what kind of connectivity that you are doing in which layer. Yeah, for example, you can have a CSP doing RNC SGSN integration via MPLS network, or SGSN MME via MPLS. So that will be the MPLS part or the network part. You can think of Node B or RNC as the transmission part. But at the end, this kind of connectivity construct different departments and construct functional scopes. Other than that, other than the core and access and transport, and these are the backbone of any mobile operator, there are other domains and other important entities like the VAS, value-added services, like the OSS, like the BSS for service provisioning, BSS for billing, for marketplaces, for e-channel, for sales. So these are the domains that construct a legacy mobile network. So with that approach, and specifically from the 4G era, and that's like typically 2009, we had like some classical segmentation of the network. We have the access, and we have the core, and we have the service, either intra service provided by the CSP or internet or YouTube or whatever. Well, what was significant in that network, that the core network, there was some sort of split between control plane and user plane. You saw these nodes like MME, right? Handling only signaling. So it was some sort of split, right? But there was no, I would say, split intra function. For example, you couldn't have SGSN or S gateway C and S gateway U. So at the end, CP and user plane processing was all in the network in one nodes. And the latency by that time and the requirements coming from the ITU and even the practical latency fulfilled by the technology, it had an average of 20 to 50 milliseconds. I made it a little bit broad because in many contexts, there are different latency figures. And even me personally, from my experience, I saw different latency figures. So I made it like for 20 to 50 milliseconds and mapped to what is there in the ITU and mapped to what is there in reality. It makes sense. So with that latency, there was no reason to go out the legacy sites or the legacy COs that have been there, central office. So if you go back to 2009, we had the concept of site, right? Or a concept of CO, where it hold the core network like the SGSN, UGSN, the MSC, the media gateway. Most of these were centralized. And as you see, because of the broad latency requirements, there was no real motivation to go out of the border of a central office or the classical sites on the national level or even in the regional level. So that was the case in the 4G. And by that time, if you go to 2009, 2010, the term edge was not there. We were always using the access. And again, the access was pure radio. and the core network kept their place in the classical sites in the national level or the central level. With some, after a few years, we had many steps as an evolution. One of the biggest evolutions that we saw in the mobile broadband or the mobile core with the introduction of the CUPS or the CUPS control plane and user plane separation in 2017. So in 2017, and that was in R14, which is actually the release that was pre-5G. I mean, it's one of the 4G, 3GPP releases that was before the 5G. The concept of CUPS was introduced. This means that if you see the third bullet, that you can have the nodes split into S gateway C, S gateway U, P gateway C, P gateway U, TDFC, which is a DPI, TDFU. So we had this kind of split, and it was a sign that once you do the split, you can easily deploy or position the splitted part in any DC, right? So there is no coupling or obligation that you split and you put the user plane in the same site of the control plane. You can easily position the user plane at any site, keeping that the interface between them or the protocol between the control plane and user plane was standardized by 3GPP, by the PFCP protocol. So you see, it was a hint, okay, that you can do the split. And by that time, in 2017, that was very really coupled with the concept of edge. Why? Because back in 2015, there was an evolution of the standardization of the HCMEC, okay, European Telecommunication Standardization Institute. They came with the MEC ISG in 2015. But by that time, because the operators didn't see any kind of compelling reason to adopt the new industry and go to the edge, right? Because there was no use case. As I told you, the set of services of 4G and the end-to-end latency was very sufficient to be handled by the classical architecture. So in 2015, the HCMEC was there. Also in 2015, there was an initiative called CORD. CORD was a central office restructured or re-architectured as data center. So from the name, it was an initiative to move the classical CO into a data center. So that was in 2015. And again, in 2015, most of us didn't see any compelling reason to go to the edge because there was no business use case and the investment was huge. But when 2017 came, and from technological perspective, we were able to do the split, this encouraged the telecom tribe to start considering the next wave. What is the next wave? It was actually the 5G. So if the 4G didn't construct any compelling reasons to go to the edge, with the 5G, and I'm bringing here the famous IMT 2020, the 5G requirements from the ITU. You saw, for example, one of the aspects is the latency, right? So you all hear about the ultra latency requirements, right? So when the 5G came, and I put here a bit broad, with 1 to 5 millisecond 5G latency requirements for the UR LLC, ultra reliable and low latency use cases, it was clear that the classical architecture of the 4G will never serve this kind of use cases, right? Because you will never be able to get a 1 millisecond or even 5 milliseconds to the national sites or the core sites. And what even gave a boost for the direction to the edge, that the 5G architecture, it came out of the box already decoupling the CP from the UP, the control processing from user processing. If now you review the 5G architecture, you will find that there are nodes only doing control processing, and other nodes like UPF only doing or handling the user plane. So that was really one of many motivations to go to the edge, and that encouraged the operators to start reconsider or embrace the MEC idea that came in 2015, and by that time there was no adoption. So I'm just getting in the definition from the HCMEC. So in a nutshell, MEC, or the multi-axis edge computing from HC perspective, making use of the split of the core network, so it's pushing the gateway or the user plane on the edge together with a set of edge applications with an intention to have a local breakout. Local breakout, it means that the user will start to get the service at the edge level. And for that time, the impression for that time that edge is the access. Well, in the next slide, I'm going to show you that it's not always the case. But that was somehow a quick, I would say, preview of it, why there was, how did we reach a conclusion that we need to go to the edge? Why was not, this was not there in the 4G, and why it is somehow coupled with the 5G, right? You always hear the edge with the 5G, but there were many motivations that were there, good efforts from HCMAC. However, I will not comment about if it's adopted or not, but there was a good contribution from HCMAC to push the telecom tribe to go to the edge. The core also give a good perception about how to change the classical COs into data centers. And then with the 5G cloud native architecture and having this kind of split, and you all know that it's based on containers, so it was easy to group all these facts and have a definition of the edge that I'm going to explain in the next slides.